Okay, Lee's asked 12 people to complete a puzzle and recorded their age versus time. What's the criticism of this? Well, I'm going to just reveal the mark scheme, what it would accept. It might accept other ones as well as this, but the main one that jumps out is the sample size is very small. If you're trying to say that this is a reflection of the population, well, if you've only tried 12 people, it's is that really enough? It doesn't say they're randomly selected, so she might have just picked 12 people that are her friends, for example. That's biased essentially. Um, it's better to kind of have you want a degree of randomness in picking people to avoid bias. So these are more minor, but yeah, they might have been in the same room. They'd obviously gain an advantage as they would if they had solved a lot of puzzles before. And one of the little things that you do need people of different ages. So sometimes when you are making a sample, you might ensure that you do get a whole spread of ages. Perhaps a 10-year-old would have been good to see how they did. But yeah, she's actually ended up with a decent spread of ages for 12 people, to be fair. But yeah, one of those. She's drawn a scatter diagram with 10 of the results, and now we're being asked to plot the other two on there. So we can see that we're going, every little square here is worth 1, and in the vertical direction as well. If I want to plot 47 in age against 21 in time, then I can go to here and up to here, and that's my 47. You should do a bit more accurate than me because you can use a ruler and a pencil a bit better, but that looks okay. And then we've got 60 against 34. So go up from 60 up to 34, and there we go. Okay, done. What kind of correlation have we got? It's not asked for the strength. What we have here is as age increases, it tends to take longer for them to solve the puzzle. And you could write that in words, or you could simply write positive correlation. That's what that means. Estimate the time it would take somebody aged 35 to complete the puzzle. We don't have anyone who's 35, and we want to kind of use all the results together. So what we can do is draw a line of best fit to demonstrate the general trend of what's going on. Now we've got a lot of people kind of coming through here. So when we have a line of best fit, we want to get the same number of people either side. So I want 6 people either side, basically, and then I'll be okay. 1, 2, 3, 4, 5, 6. All right, I'm happy with that. Your line might look slightly different, but it's just, that's not as important because it's a bit subjective how to draw your line of best fit. If they're 35, right, let's read off the graph. So from here, I can see that I would expect it to take them 11 minutes if I line that up. If I do my dotted line on the graph with a ruler, ideally, then that's good working. And I'll write 11 minutes. Show your working, like I have shown my working on the graph. I've got my line of best fit and I've got my dotted line. I don't need to do anything else. Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. Is Lee correct? Well, what could we do? We could either find the percentage that did complete the puzzle in under 30 seconds, or we could find out 80% is a bit of a tricky one because we've got 12 people. I think I'm going to find a percentage in this case. So I just think that's going to make the most sense. If I go along here, I can see that essentially, did I write minutes there? Sorry, that should have been seconds. So 80% of the 12 people completed the puzzle in under 30 seconds. We can see exactly who did and who didn't. So let's work out who didn't. This person didn't, and this person didn't, and this person didn't. So actually 9 of the 12, 9/12 solved in under 30 seconds. Well, you could change that to 3/4, and then you can actually identify that that is 75%. Another way of doing it is to do 9 divided by 12 times 100. That will give 75%. But what we can see is that Lee is not correct. Lee is not correct because she said at least 80% and 75% is not at least 80%. The other way you could do this is you could find out what 80% of 12 people is, which would end up being a decimal. That's why I didn't want to do it that way. So 10% is 1.2, times that by 8. We've got 9.6, and then you could, I suppose you could compare that 9.6 with the 9 that actually did it in under 30 seconds and say, no, actually that's not correct for similar reasons. So something like that anyway, showing that Lee is not correct.